All right, now that we've looked at how to find an antiderivative or a general solution to a differential equation, we want to look at how to find a particular solution. So before I get into that, I want to look a little bit closer at our general solution. So if I look at this example here, I have the integral of 2x plus 2. I should have had a dx on the bottom. Sorry about that, I forgot to have that on there. If I go ahead and integrate this, so using my integration rules that we've been talking about, I'm going to have 2 times 1 over, it currently has an exponent of 1, so I'm going to say 1 plus 1, x to the 1 plus 1, plus, constants always just tack an x on, plus 2x, so I know this is going to become 2 and cancel, so I'm going to get x squared plus 2x plus c. So what does that c stand for? Well, we've talked about how that c can be any constant. So here's my graph. So notice if my constant or my c was a 4, I would have this quadratic equation or this parabola here. If my constant was nothing, I would have this parabola here. If my constant was -3, I'd have this parabola here. So notice that c, all it does is take our same function and shift it vertically. If you're wondering why it shifts it vertically, if you remember back to when we talked about putting a quadratic equation into vertex form, if I change this into vertex form, you would see that I'm adding to the outside of my function, and as we've looked at many times in the past, adding to the outside of a function is a vertical shift. So it's just taking the same function and moving it up and down. So now let's look at a particular solution. When we talk about finding a particular solution, we are talking about finding C. So I want to find what C is. So all I'm going to do to find the particular solution is go through the same steps that I've already went through and then add a couple steps onto the end. So if I want to find the solution or the particular solution to this differential equation, I will start by taking its antiderivative. So what was my function before I differentiated it? Well, it was the integral of 2x plus 2 dx. Well, notice I've already integrated that up here, so I know that my function was x squared plus 2x plus c. So now I know something more about my function. I know it's passing through the point 1, 7. I'm going to use that to help me find c. So this is essentially telling me that when x is 1, y is 7. So I want to find out what c value would force that to be true. I'll find that by plugging 1 in for x and 7 in for y. So I'm going to plug 7 in for my f of x equals 1 squared plus 2 times 1 plus c. Well, I know that this here is going to give me 1 plus 2, so 3. So if I subtracted 3 from both sides, I would get 4 equals c. So now that I know what c is, I'm going to actually write out my particular solution. Please don't forget this step. I will take credit off. My particular solution is x squared plus 2x, and in place of c, I will put 4. So notice it's going to be this one right here. Let's look at 2 more examples with this. Feel free to pause the video and try them on your own at any time. All right, so in example 2, I want to find a particular solution to this given, again, differential equation. So what was it before it was differentiated? Well, before I differentiated, my function was, I can find that out by integrating. I know that in order to integrate this and use some of those rules we looked at, I would rather that 2 was on top, so I am going to write it as x to the -2 dx. And then following my power rule for antiderivatives, I get 1 over -2 plus 1, x to the -2 plus 1, plus c. Well, that becomes 1 over -1, so I have negative x to the -1 plus c. I'm going to move that to the bottom and say my function is -1 over x plus c. Now I'm going to use this information to figure out what c is. Well, this is telling me that when x is 1, my f of x or my y is 0. So I'm going to plug that information in, giving me 0 equals -1 over 1 plus c. So 0 equals -1 plus c, which means c must be 1. So taking my final step and writing out my particular solution, I get f of x equals -1 over x plus c. Notice to take that final step and get my particular solution, all I'm doing is taking my general form of the solution and I'm plugging my c in. And let's look at one final example. So I want to find the equation for y if my differential equation, if dy dx is this function here. So first thing I'm going to do is anti-differentiate. So when I take the integral, I know that I'm going to have to distribute that 3, or I guess I could pull the 3 out as well. So let's do that. Let's practice doing that. So I'm going to put the 3 out here since it's a constant. I could have also distributed it in. It did not matter. And I'm going to go ahead and differentiate this, or excuse me, integrate this. It's 3 times whatever I get. So I get 1 over 2 plus 1, x to the 2 plus 1, 4x plus c. So I get 3, and notice I could keep the c in the parentheses here. C stands for just some number. So some number and times 3 is still just some number. So it doesn't matter if I distribute that 3 or not. So I get 3 times 1 over 3x cubed plus 12x plus c. These cancel, so I get my general solution is x cubed plus 12x plus c. To solve for c, I'm going to plug 1 in for x and 2 in for y and use that to help me find what c has to be in order to get that point. So I see that I get over here 1 plus 12, so I get 13. So if I subtract 13 from both sides, I get a c value of -11. I make sure and write my final answer as my general solution with my c plugged in. And that's it. There's my particular solution. So now we have a way to find a general solution and a particular solution. Again, remember the only difference is going to be where that function gets shifted in terms of up and down on the y-axis.